Hello. So I'm here to talk about the Data Lakehouse. Who here has heard of the Lakehouse before? There's about 1 million sessions this week, yeah. Who here is using a Data Lakehouse? Has implemented one? Well, okay, 1 or 2 people. Yeah, Mikey. Okay, so my name's Craig Porteous. I am a principal data engineering consultant. I work with advancing analytics. I'm lucky enough to be awarded the MVP award, and I think it's since about 2018 now. And I'm also a Databricks champion, which basically means I talk about Databricks a lot and passed a couple of exams and things. When I first heard about the Data Lakehouse, I'll be completely honest with you, I think it was about 3 years ago, ish. I thought it was just someone having a joke on Twitter, like taking 2 things and kind of smashing the name together and making fun of it. It doesn't sound like a technical term. It doesn't sound like a business term. Warehouse, data marts, lots of serious things. They sound like actual real things. But as I kind of got to know what it meant and what's under the hood, it started to make sense. The name does sound a little bit gimmicky, but to be honest, it kind of fit requirements. It fit what that evolution of a data platform looks like. So there is a lot of hype around the Data Lakehouse, and that's probably part of the problem. In 2022, it peaked on the Gartner curve, hype curve for data analytics. I think Simon Whiteley was talking about hype around data analytics yesterday. Databricks are said to have coined the term, though I don't know if there's any kind of official backup to that. But it is part of their main marketing strategy. And they're worth $38 billion, so there must be something to it. But lots of other vendors are talking about it as well. It's not just Databricks. It's not a proprietary tool. It's not something that's a product that you need to go with Databricks to get. So if it's legitimate, if there's a lot of companies talking about it, there's a lot of vendors talking about it, what problem is it trying to solve? So to understand that, we need to kind of think about, or to understand that and arm you with the information that you need to plan your next data platform, if that's a lakehouse, or continue the one that you're building. We need to first talk about the history of the lakehouse. I'll talk a little bit about what makes that special, or what makes the lakehouse special, and then we'll talk about what different technologies and skills you need to consider for the lakehouse, all in 20 minutes. So to start with a pretty solid reference point for everybody, or I'm hoping, I'm going to just briefly cover the data warehouse. So this is a fairly recognizable reference point. It's been around since the 80s, this sort of approach to things. You've got sources, you bring them into a relational database, and you do something with the data. You stage it, it's dropped in its source format, you clean the data, you transform it, and you turn it into a nice model that can be consumed for analytics at the end, whether that was reporting services or Power BI or whatever iteration. So it's a nice recognizable platform. It's been around for a long time, and it's solid. But it's a rigid platform. It's not very flexible. And this is where we start having a look at scalable data platforms, and this is where the data lake starts to come in. So the data lake gives us a good storage layer that's flexible. It's cheap as well, so we can start to consider bringing in a lot more data and working with bigger data sets. And in doing so, we're separating our compute and our storage. So we've now got 2 separate platforms for them. We can scale up our storage as need be without affecting the compute. We can use as much or as little compute as we need to, and we've got a lot more flexibility there. So that original picture, we've got sources, now comes into a new storage layer. We're kind of doing the same things, staging to clean, raw to base, whatever you want to call it. And we've got that compute engine over the top, which in my examples is Databricks. But to surface that, this next iteration, the modern data warehouse, was still taking that out and putting it into a relational database as a faster way for people to interact with it and surface that with Power BI or reporting services or any other kind of technology. So it's an improvement, but it's not quite there. We can scale easily, but it's essentially a free-for-all. All of that data that's coming into our data lake, we don't have any proper control over it. We can put in processes to manage schema. We can do a lot on the surface, but essentially any schema changes that come through can entirely break our tables under the hood. Files, nothing's enforced in file types like CSV, for example. Governance and structure are just really hard. So we still have that warehouse layer at the end. We've just essentially added a little bit more complexity with that flexibility. The kind of next iteration of this is to start to consider streaming data. So the LAMBDA architecture describes that same sort of platform, but as two separate streams. Essentially, we've got a hot path and we've got a cold path, and our streaming data essentially skips a lot of that and goes straight to the end. So that's great. We can deal with IoT data, we can get some streaming data in there, but we're again adding more complexity. We've got multiple different services, multiple different tools that we're dealing with. And this is where the Data Lakehouse comes in. The Data Lakehouse takes all of those different data source types, our streaming data, our batch data, and pulls them together and processes them through a single platform. So we've got that same flexible, scalable storage. We've got the same independent, scalable compute that we talked about before. But the difference here is that little piece in the middle inside the storage account, and that's our Delta file format. This is what makes the difference. This is what makes the Data Lakehouse. That gives us ACID transactions. It gives us schema control. It gives us schema flexibility as well, and so much more. And we no longer need that warehouse layer. If you look at how Databricks describe it, they call those layers bronze, silver, and gold. But essentially under the hood, we can have that same model, that data model in our curated zone. It could be within Power BI on the surface, but we've got that flexibility, but it's still a recognizable layout, still a recognizable format. So I said Delta is essentially the key point here, and this is the linchpin of the whole Data Lakehouse and the whole purpose of it. So what is Delta? So Delta is a file format. It's entirely open source. So it never used to be. Most of it was open source. Some of it was proprietary to Databricks, so you had to use Databricks to get specific features. Around about June last year, as part of the Data and AI Summit that Databricks run, they made the whole thing open source. So regardless of you using Databricks, if you use Synapse, if you use any other tooling, and you're looking at Delta under the hood, it's completely compatible across all of them. So you're not tied into a vendor, and that's one of the key things that's a benefit of the Data Lakehouse. I say it's a Delta file format. It's really just Parquet under the hood. So it's still the same Parquet files that will give us structure, but with Delta, it gives us a transaction log on the top of it. And being able to do that, we can get ACID transactions. So having that transaction log means that we've got ACID transactions to be able to query our data in a consistent way. And that transaction log is key to giving us that single source of truth. Because we've got that transaction log, we can also do time travel. So we can look at our data as it appeared at a specific point in time. As I mentioned, we've got schema evolution and schema control, or schema evolution or schema control. So as data evolves, as it comes into your data lakehouse, we can automatically absorb changes to the schema, minor changes where we've got additional fields coming in or where data types are increasing, for example. Or we can lock that down entirely and say it has to fit this specific schema or it's getting rejected. And then, as I mentioned, we can deal with both batch and streaming data, and it comes in the same way. So that's the real kind of backbone of the Data Lakehouse. But what does that look like on Azure? So if we look at the Azure Data Lakehouse, these are some of the kind of tools that we would potentially use. So for our streaming data, that would run through Event Hub. We've got our batch data that would just come through, and we can utilize Data Factory as an orchestration tool, or we could be using the integration pipelines within Synapse. All of that storage is based on Azure Data Lake Storage Gen 2. And our compute engine, again, could be Databricks. It could be Synapse, again, if you were going for Synapse across the board. And then we can surface that. We can surface that straight into Power BI, because Power BI is able to pull from, read from Delta files, but we can pass that through a serving layer, whether that's Synapse serverless or it's Databricks SQL warehouses. So you've got a lot of options there, just considering Azure. But the benefit of the Data Lakehouse is you've got a lot more technologies that you can utilize. Whether you're on GCP, Google Cloud, or AWS, then you've got different tools that you can use. For that storage layer, I've mentioned Delta Lake, and the reason I talk about Delta Lake the most is that it's the tool that I use the most. It's also the tool that appears to be the most widely supported as well. There's also the ability to store your data in Apache Hudi and Apache Iceberg. But I have a challenge for anyone. I'll send like a whole box of swag if someone can get me an impartial comparison between all three of those storage types. There's some interesting ones I've came across, and then right down at the bottom in fine print is it's sponsored by Apache Hudi or some sort of organization associated with them. So it's very difficult to get kind of get an impartial review across them. And again, you can serve that with a plethora of different tools as well. If you even got Snowflake in there. So with this new platform, or what is essentially the same thing we're doing with some different technologies in a different file format, you might be asking the question, where's the skills gap here? So do I need to have a completely different team? Do I need to completely upskill my team to manage this? And I'm going to play the consultant card and say it depends. Essentially, you're looking at using Spark as a primary kind of engine here, especially if you're using Databricks. But you don't need to reskill everyone. You can use SQL to entirely to work with the Data Lakehouse entirely. Spark supports SQL. It's an equal language to the other two options, which are Scala and Python. And performance is the same across them. If you're using Azure Synapse, SQL, you can use SQL across the board there as well, and you can interact with your data, you can transform your data with SQL, so it's familiar tools and familiar languages. The real benefit that you get out of the Data Lakehouse is if you use Python or Scala to actually build in some automation, start to build out a proper metadata-driven platform and a metadata-driven framework, and that's where you start to get that benefit within the Data Lakehouse of your orchestration layer and actually processing tables in a robust and repeatable way rather than dealing with everything individually. And that kind of covers everything on the kind of whirlwind tour of the Data Lakehouse. And that's everything. Has anyone got any questions? That was a fast 20 minutes, or 15-ish. No questions at all? One up there. Sorry, I can't hear you. Have we got any microphones someone could run up with? So So where would you use a data lakehouse instead of a data warehouse? Is that what you said? Yeah.
What is the difference between the structures of the two?
The structure. So your data warehouse is based in SQL. You've got it's a relational database where you've got your tables in a kind of a relational format, and the data lakehouse is essentially built upon files under the hood. So you've got the ability to scaling up your storage separate from your compute, but you've not got the same kind of restrictions with being stuck with a single SQL Server platform, and the Lakehouse has got that ability to kind of scale in whatever direction you need, whether it's scaling up or scaling out with the storage and compute. So you've got more flexibility to deal with different data types and much more data, essentially. Does that help? Yeah?
Can you achieve the same query speed with a lakehouse as SQL Server?
So you've got different workloads, so you'll have different kind of speed. Sorry. Yeah, so have you got the same performance with a warehouse as a lakehouse, is that right?
If there's any difference, like, can you get the same performance?
Yeah, so your data lakehouse is going to be more performant when you're dealing with larger data sets and larger files and larger sets of data. But with the warehouse, it's obviously you're working with SQL, so kind of smaller queries and things like that are always going to be quicker with the warehouse.
Is it possible to achieve like sub-second queries with the lakehouse?
Yeah, certainly, yeah. I mean, the main kind of part of this is what you want to be doing with the lakehouse and warehouses as well is building out a lot of your transformations as it goes through each of those layers and builds up, so that when it gets to that model point at the end, that people are just querying the data that they need to see. But one of the other benefits is the fact that because we've got that cheap storage and we're putting all of our data in there, we no longer have the requirement to clear out our data in like our clean and our stage layers. So you can have your end users, your business analysts that are interrogating that curated data at the end, whereas your data scientists, for example, could be working with that base data or the raw data. Your data analysts can come in and look at the base data, and it allows you to keep all those data sets there in full so that they can deal with the data at different stages of transformation and aggregation. Great, yeah. Yeah, so yeah. So what's the difference between raw and base or bronze and silver, depending on what kind of naming convention you go with? So generally what you would do is do one action, one sort of transformation action between each of those layers, and raw would tend to be your data as it's landed in a delta format, so you could still have erroneous data in there, you could have fields that aren't named properly, you haven't done any sort of transformations or restrictions. And as you move that into base, you would potentially cleanse that data. You could apply regex rules. You could do different types of logical and physical rejection. So you can actually mark data as potentially erroneous or just strip out entire rows of your data. So you've got different kind of use cases for that, where there might be your data science team, if you have one, may want to interact with that data before any of that has been done. Great. No more questions? Oh, one up back there. Cost differences. It depends, really. So it's a really, really difficult one to answer because a lot of it's going to depend on how you're processing the data and what the data volumes look like. This platform being cloud-based, you're paying for what you use and you're paying for how much you use. So if you've got an enormous amount of data but you only process it once a week, then your processing costs are going to be pretty small, and your data costs, your storage costs are going to be higher, but to be honest, the storage costs are going to be pretty low anyway. You can store terabytes of data for pennies. So The difference, the real kind of difference there is changing that mentality, especially if you've got on-premises data warehouses where you have to buy actual physical tin and project what that's going to look like in 5 years' time, so that you've got this big beefy server that's not really getting used because we expect to ramp up as we get towards the end. Whereas that kind of cloud-based usage process means that you're only paying for what you use. I think that's all we've got time for, but if there's any other questions or anything, I'm going to be at Community Corner. Feel free to drop by and say hello. Thank you.